We've talked about horizontal asymptotes, end behavior approaching infinity, right? Where is our function going? We've talked about vertical asymptotes. What happens when we divide by zero? Well, we have a infinite discontinuity there. Now we're going to look at slant or oblique asymptotes. A graph has a slant asymptote if the degree of the numerator equals the degree of the denominator plus 1. So it's only when it's plus 1. If it's plus 2, no dice. So to find the equation of the slant asymptote, we need to use long division. So we're going to start with our numerator going inside. Got x squared plus x minus 1 divided by x plus 3. So we'll go through and do our long division. Okay, what do we need to multiply x by in order to get x squared? Well, we multiply by x. Distribute that through. Remember that we're subtracting this entire quantity. So that goes away. X minus 3x is negative 2x. We got to bring down the minus 1. So then we need to think about what do we need to multiply x by in order to get negative 2. Subtract 2. And we get negative 2x. Negative 2 times 3 is negative 6. This goes away. Negative 1 plus 6 is equal to 5. And there we have it. Our slant asymptote is this value right here, x minus 2. So that gives us an equation of a line, y equals x minus 2. So when we go to graph this function, we know that there's a vertical asymptote at negative 3 because that's where we would be dividing by 0. Vertical asymptote, 1, 2, 3. Put that one in. And then x minus 2, well, that means I have a y-intercept of negative 2. And then we go up 1 over 1. Up 1 over 1. Right, not perfect. Down 1, backwards 1, down 1, backwards 1. So this would be our slant asymptote. To continue graphing this,